Now at this point, happily, or maybe not so happily, there's not an alternative to the quotient rule, because there's really not a better way to write this. We can't just distribute something across the parentheses and use the sum rule, power rule. This is a quotient. We're kind of stuck with this quotient. So to find the derivative, f prime of x, we'll just prepare a great big fraction, and we'll begin with the denominator, and we'll put that in the denominator, and we will square it. Whatever's in the denominator, put it in the denominator, square it. While we're thinking about it, write it down again. X squared plus 1. What that does is it reminds me not to take the derivative of the x squared plus 1 right there. I would think it would be easy to say, well, is it g in the first part, or is it g prime? You know, is it gf prime or g prime f? Well, if you remember what goes first is what you just wrote down and squared in the denominator, it helps to clear that up. Now, multiply that by the derivative of the numerator, and then put a minus, because the quotient rule has a minus. Then, since in this first expression it was the denominator times the derivative of the numerator, we got to reverse that. It's going to be the numerator, 2x minus 3, times the derivative of the denominator. Just like that. Once you have all that written down, it's just a matter of differentiating, simplifying, combining like terms, maybe simplifying some more. So we take the derivative, f prime of x equals, well, the derivative of 2x minus 3 is just 2, slope of that linear expression, minus 2x minus 3, derivative of x squared plus 1, just 2x, using the power rule on the x squared. Derivative of 1 is 0, so that doesn't contribute anything to the derivative. And we still have x squared plus 1 quantity squared in the denominator. And we have an expression to simplify in the numerator. Give myself a little bit more room down below and then off to the right-hand side. F prime of x equals 2x squared plus 2 minus, a little tricky here, but we can handle this. It's minus whatever 2x times 2x is. And then it ought to be plus whatever 3 times 2x is. Maybe it'd be good to think of it as negative 2x times negative 3. It's going to be plus 6x. Everyone feel good about plus 6x there? Yeah. So x squared plus 1, quantity squared in the denominator. Just about there, I think. Combine the x squared terms to get 6x squared. No. Opposite signs there. Negative 2x squared. Negative 2x squared plus 6x plus 2 all over x squared plus 1, quantity squared. Now I suppose if we could factor the numerator in such a way that there was a factor common to something in the denominator and we could reduce it, that would be a good thing. Ordinarily I might not worry about factoring the numerator, but maybe factor out the negative 2. Inside we get x squared minus 3x minus 1. I believe that trinomial is prime. So it would look like this.
So that's the answer.
That is the final answer, yes. Now we don't want to lose sight of what we're doing here. If we had this original graph and we had a point, we want to know what's the slope of the tangent line at that particular point. Then we take that x-coordinate and evaluate this expression, and that would give us the slope of the tangent line to the original graph at that particular point. There it is.